Question 2 on transpiration. Students measured the rate of transpiration of a plant growing in a pot under different environmental conditions. The results are shown in the table. So you've got three different conditions, A, B and C. Still air at 15 degrees Celsius, moving air at 15 degrees Celsius and still air at 25 degrees Celsius. During transpiration, water diffuses from cells to the air surrounding a leaf. 1. Suggest an explanation for the difference in the transpiration rate between conditions A and B. So A, you've got still air at 15 degrees Celsius, and B, you've got moving air at 15 degrees Celsius, but you've got a transpiration rate of 1.2 and of 1.7. The moving air removes water vapour. It increases the water potential gradient and therefore there is more diffusion, more evaporation. That gives you your 2 marks. So 1 for removed water vapour and then 1 for increased water potential. Then 2. Suggest an explanation for the difference in transpiration rate between conditions A and C. So A is still air at 15 degrees Celsius, C is still air 25 degrees Celsius. A, transpiration rate is 1.2, C, transpiration rate is 2.3. Well, the difference is difference in temperature, but it's looking for increased kinetic energy, water molecules move faster, increased diffusion or evaporation. So 2 out of the 3 will give you the 2 marks. Here is a typical AQA graph question. Scientists investigated the rate of water movement through xylem of a twig from a tree over 24 hours. The graph shows their results. It also shows the light intensity for the same period of time. Describe the relationship between the rate of water movement through the xylem and the light intensity. So here the answer is looking for the relationship between water movement and light intensity. It's looking for a positive correlation. As light intensity increases, so does the rate of water movement, or it follows the same pattern, or it's directly proportional. The next question. Explain the change in the rate of water movement through the xylem between 0600 and 1200 hours. So you need to go to the graph and look at what is happening between 0600 and 12. Now you need to be very careful here. The question is not describe but explain. Have a go. You need to recognise to get the marks for this question that between 0600 and 12 that the sun is going to come up and it's going to become light. Therefore the stomata will open, photosynthesis increases, transpiration increases, more water is pulled up, and there is cohesion between the water molecules by cohesion tension. The scientists also measured the diameter of the trunk on the tree on which the twig had been growing. The diameter was less at 12 o'clock than it was at 0300 hours. So 0300 hours is 3 in the morning. Explain why the diameter was less at 12 compared to 3 o'clock in the morning. What you need to do with this question is think what would be different between these two different times that would cause the diameter to be less in the tree trunk. The examiner's report says for this question that it appeared to be unfamiliar to all but the best candidates. The structure of the question should have led candidates to realise it was testing the same basic principle as the previous question. The question was worded in such a way as to encourage candidates to explain the lower diameter at 12 o'clock. The reasons for this lower diameter was the water was pulled up the trunk and was moved up at a faster rate. The water column was under tension, and then you had the sticking between water and the cells and the walls and the xylem, and it pulls the xylem in. Then the final question for 6 marks. Arteries and arterioles take blood away from the heart. Explain how the structure of the walls of the arteries and the arterioles are related to their function. The mark scheme is looking for a discussion of the elastic tissue, muscle and epithelium. Now the elastic tissue is for 3 points. The elastic tissue stretches under pressure when the heart beats. It recoils or spring backs, and it evens out pressure flow. The muscle, well, the muscle contracts, reduces the diameter of the lumen, vasoconstriction, or it constricts the vessel, and this can change the flow or pressure, or you can have the converse of the muscle. And then the epithelium, it's smooth, so it reduces friction, blood clots and less resistance.